If a projectile is fired with a velocity of v sub 0 at an angle theta, then its range, the horizontal distance it travels in feet, is modeled by r of q equals the square of v sub 0 times sine 2 theta divided by 32. If v sub 0 equals 630 feet per second, what angle in degrees should be chosen for the projectile to hit a target on the ground 3,560 feet away? Round to the hundredths place value. Because r of q is the range, we set r of q equal to 3,560. And because v sub 0 is the initial velocity, we set v sub 0 equal to 630. This gives us the equation 3,560 equals the square of 630 times sine 2 theta, all divided by 32. And now we need to solve the equation for theta. We'll first solve the equation for sine 2 theta by multiplying both sides of the equation by the reciprocal of the square of 630 divided by 32, which is 32 divided by the square of 630. Simplifying on the right, 32 divided by 32 simplifies to 1, and so does the square of 630 divided by itself. We now have 32 times 3,560, all divided by the square of 630, equals sine 2 theta. And now we'll solve for 2 theta by taking the inverse sine or arc sine of both sides of the equation. Simplifying, we now have inverse sine of 32 times 3,560 divided by the square of 630 equals, on the right side, inverse sine of sine 2 theta equals 2 theta. And now to solve for theta, we'll divide both sides by 2. Simplifying, we now have inverse sine of 32 times 3,560 divided by the square of 630, all divided by 2, equals theta. And now we'll go to the calculator and get a decimal approximation for theta. Recall that we're told to round to the hundredths place value, or 2 decimal places. We do want the angle in degrees, and therefore it's important to make sure the calculator is in degree mode. I'm using the Desmos Scientific Calculator. The calculator is in degree mode. For the inverse sine function, we press Functions, Inverse Sine, click on the main tab. Let's go ahead and use the fraction format button here on the right. In the numerator, we have 32 times 3,560. In the denominator, we have the square of 630. Right arrow, divided by 2, and enter. To the hundredths place value, theta is approximately 8.34 degrees. This is the angle that should be chosen in order to hit the target 3,560 feet away when the initial velocity is 630 feet per second. I hope you found this helpful.